Hello everyone! Until now we have looked into grammars mostly as devices for producing inputs. However, grammars have an important and possibly even more important usage, and that is parsing inputs. With a grammar, we can decompose an input into all the individual elements that make up the structure of the language. This usage of grammars is actually far older than the usage of grammars for production, and it's also arguably more important depending on your perspective. If you are, say, building a compiler or building any infrastructure that handles complex structured inputs, then grammars and building a parser with the help of grammars is absolutely necessary for you. If you are in security testing, then of course the second aspect of using a grammar for fuzzing is more important for you. Well, the interesting thing is that you can actually combine both, namely using a grammar first for parsing an input and then mutating it and then writing it out again, all according to the rules of the language. We are using parsers often in this book as a part of essential infrastructure. So today in this video, I'm going to focus only on how to use parsers and how to deal with the parsers that we have in here. However, the chapter that we have on parsing fully implements two of the most modern parsers that exist. And it comes with plenty of code and plenty of explanations, which you can all dig into if you're interested to learn how parsers work and how modern parsers are implemented. So let's go right into action here and let's make use of a parser to parse existing inputs. So what we're having here is again my Scratchpad. If only it would arrive. Here we go, and here we have our Scratchpad where we can enter our code. And the interesting thing here is, of course, the parser class, where we can make use of two very important kinds of parsers. We do have the PAG parser, which is super efficient. However, it is slightly restricted in the kinds of languages that it actually can use. And we have the early parser, which actually can handle any kind of grammar and which therefore is the first choice unless you are concerned with efficiency or unless you experience efficiency problems. That's more the way to put it. Again, we're having our expression grammar in here, so you've seen this a couple of times. I don't want to comment on that. And now we want to make use of this expression grammar to actually parse an input. So what we do here is we create a parser. So let's first start with the early parser, which is the most versatile of these and also the one that will actually go and produce all kinds of possible inputs. So we instantiate the parser using the grammar, nothing too complex with that. And then we have a method called parse, which we can invoke. So I'm calling p.parse, and this gets as a parameter an input that is formed according to the rules of the grammar. For instance, in our case, an arithmetic expression. So, and what this function parse returns is a list of derivation trees as we have seen them already in the chapter on grammar fuzzing. So here we go, trees, well, that's it. What happened? Trees, what does trees look like? Trees by itself is not very interesting because this actually is implemented as a generator object, meaning that it will be evaluated on demand, but we can actually access its individual elements or convert it into a list. And trees of, oh, what am I doing here? Oh no, this doesn't work actually. Too bad. Okay, we have to convert it first into a list, and then we can access all its individual elements. So converting it into a list actually gives us the whole list of possible expansions, and then we can look into the first element and we see that it's actually a derivation tree. well, I see that it's a derivation tree. You may not immediately see that, but it becomes clearer if we actually go and, oh no, sorry, we have to do this one more time here. Here we go, and now we have accessed the first element of our tree. And if we go and we can now display the tree using our visualization capabilities, and then you'll see that we actually have a nice derivation tree in here. That is our expression 2 plus 2, which we have up here, actually consists of start and then an expression and term plus expression and so on. This exactly looks like a derivation tree as it would have been produced by a grammar fuzzer. And of course, we can now go and navigate through the tree, replace individual elements by other elements, or go and say, okay, I'll go through that tree and I'm going. So since I've parsed the entire thing, I'm now going to go and take this expression and replace it by a subtree that I generate from scratch again. So being able to parse inputs, existing inputs, and then mutating them offers even more opportunities for fuzzing, because you are having the grammar, so you stay within the realm of syntactically valid inputs. And the second thing is that if you can parse big existing inputs, these inputs typically also satisfy some constraints which may not be part of your grammar. Suppose you have a grammar for C programs, and if you parse an existing C program into a derivation tree, not only will it be syntactically valid, but it will also be semantically valid. For instance, all the identifiers that you use already have been declared, the program is type correct, and other features that are hard to express in a context-free grammar. And if you then make small mutations to that C file, and feed this into a compiler, you will still have inputs that are syntactically correct according to the grammar, that will mostly be type correct and mostly be semantically correct according to the semantic rules of C, because you're only making small changes, so you have high chances of being correct. And this is how you can then very thoroughly test fuzz. For instance, a C compiler, take a set of test inputs, take a set of C inputs, read them in using the parser, mutate them, and then produce new inputs from that. This whole business of reading things in and changing them again, and possibly even doing so being guided by the program at hand, is something we're going to explore in later chapters, notably gray box grammar fuzzing. So far, this is a very helpful piece of infrastructure for you if you ever want to make use of existing inputs. And I encourage you to also deeply look into the chapter that follows, such that you have an understanding of how parsing, and notably efficient and modern parsing, works. So, with that, enjoy the read, enjoy parsing, enjoy fuzzing, enjoy parsing and fuzzing. Enjoy. Thank you.